Math 186 students. This is your instructor, Mrs. Thomas. And I have zoomed in on chapter 11, which is our IV therapy critical care applications, so that you will be able to have some practice problems. And you will be able to work on those in order to help you with chapter 11. On chapter 11, it is, I'm just looking, it is on page, let me see where it starts, page 213 through 214, and I always make sure you read the chapter prior to, so that you will have examples when it comes to critical care and using IV therapy. Of course, I will give you examples and practice problems. Make sure you are able to, just in case you have to stop the video, but I know you have your textbook already. These are just some examples in your textbook. Titrated IV fluids. As well as your assignment, your homework assignment. And this is definitely very intense. So I know there are 1 through 33 problems, but I just need problems 1 through 10 only. 1 through 10 only. So let's get started. So we're going to start with the practice problems. Okay, for number 1, it says a physician prescribed an antibiotic solution of 250 milligrams in 100 milliliters of dextrose 5% water at the rate of 10 micrograms per kilogram per minute for a patient who weighs 148 pounds. The nurse knows to set the infusion pump at blank milliliters per hour for the patient to receive blank micrograms per minute. Okay, so let me gather some paper here. And I always start off with writing down the information that I was given. And this is just grabbing the information, the 250 milligrams, writing it. I always kind of write it down so that I will see what I have to work with as far as information and numbers. And the person is 148 pounds. Okay, so this is what I am working with based on the information that is in the problem. Okay, so first I want to start by, and this comes also as examples in the book, I want to start with converting like terms. Okay, so let's convert our like units. Okay, also I want you to remember that 1 milligram equals 1,000 micrograms. You're going to need that throughout this text. Okay, so let's start with the person's weight. We always start with their weight. If it's given how many pounds, we want to change that to kilograms. So we know that 1 kilogram, and all of this is also in your book, equals 2.2 pounds. Okay, and the person weighs 148 pounds, so pounds to pounds, just like we talked about in class. Okay, so they leave this proportion with X on top in the numerator spot. Now we want to cross multiply. Okay, so we're starting with the person's pounds, changing our pounds to kilograms in order to work the formula method. Okay, so I want to cross multiply 2.2 pounds times X equals 1 times 148, so that's 148 pounds times kilograms. I want to divide both sides by 2.2 pounds. Okay, that will cancel out, of course, leaving you with x equals, and we're going to divide 148 divided by 2.2 and get the number of kilograms. So 148, that's how much the person weighs, divided by 2.2 equals 67.2. So let's just give it an even round, 67. Okay, so 67 kilograms. Okay, next, all right, so we've conquered this portion of it. Now let's change our milligrams here. Okay, our milligrams, we're just looking for making sure we have all of our information. So this is going to be next that we're looking at. Milligrams to micrograms, that's where the formula comes in. So this has various steps to it. So this will be like step 1. This next part will be step 2. Okay, so 1 milligram equals 1,000 micrograms. Okay, and we're changing our 250 milligrams to micrograms. So I want you to place 250 here over X. We're going to cross multiply. So that gives me 1 milligrams times X equals 250 times 1,000. Okay, 250,000. All right, micrograms times milligrams. Got to get it all in there. Now I want you to divide both sides by 1 milligram on each side. That will cancel. The milligrams cancel on that side. Make sure I zoom in so you'll be able to see that. 250,000 divided by 1 is still 250,000 micrograms. We're going to need that. We're going to need the micrograms as well. Okay, we've conquered these two. Okay, well, Ms. Thomas, what's next? We're going to conquer this portion next. So we're going to write down our 10 micrograms per kilogram per minute. And we're going to multiply that times our kilograms. All right, remember we got this as a kilogram. So we're going to multiply that times 67. Y'all need to block that out so you don't get confused. Okay, so that will cancel out my kilograms here, just like with dimensional analysis. And I want you to multiply 10 times 67. So 670 micrograms per minute. And all of this is necessary, especially with being a nurse and caring for patients. Okay, so that gives me 670 micrograms per minute. Okay, well, Ms. Thomas, well, what do I do next? Okay, well, next I want to look at the formula method. Okay, so the 600, and so we're going to take this answer, 670 micrograms per minute, and we're going to divide that by our micrograms. So we're going to divide that by 250,000 micrograms. All right, notice microgram to microgram. Okay, then we're going to multiply, come back up here, times, this is the last step here, the 100 milliliters. Okay, so let us put that in the calculator. So 670, which is right here, divided by 250,000 equals 2.68 to the negative third power, okay? Then I'm going to multiply times 100, which gives me 0.268, okay? 0.268, okay? I think I rounded it to 0.2 3. But if you did not round and you left it as 0.268, that is perfectly fine. Well, Ms. Thomas, that's not the answer in the back of the book where we're not finished. Because now when you're thinking about IV, you have to think about the fact that the IV is running into the patient's arm, okay? So therefore, you need to be thinking of how many minutes. So you always, in critical care, you want to multiply by 60 minutes, okay? If you don't have any run time, if they don't tell you if it doesn't say the IV runs for 30 minutes, the IV runs for 8 hours, then it's automatically 60. So we want to multiply that times 60 minutes, okay, which yields 16.08. Of course, I want you to round that per hour. So the answer is 16 milliliters per hour that the IV needs to run into the patient. 16 milliliters per hour. Okay. All right. We're not finished. Okay. Because this is definitely extremely important. All right. Let's try another one. Number 2. Okay, let me zoom out so I'll be able to read the whole thing to you. A patient who weighs 200 pounds was prescribed 300 micrograms of a medication and 250 milliliters of normal saline to infuse at 0.5 micrograms per kilogram per hour. The nurse will set the infusion pump at blank milliliters per hour for the patient to receive blank micrograms per hour. Okay, so let's look at that. Now, I always write down what I'm given so that I won't have to continue to look back at the problem, which you can if you want to. 200 pounds is what I'm given. 300 micrograms, 250 milliliters, and 0.5 micrograms per kilogram per hour. And this is just the information I'm given for number 2. Okay, so I write that information down. Okay, let me look back. This is the information. So where do we start? We're going to start by, since the person weighs 200 pounds, we always start with changing the pounds to kilograms every time. Okay, so 1 kilogram, this is in your text, is equal to 2.2 pounds. The patient weighs 200 pounds. So I want you to cross multiply. Okay, that yields 2.2 pounds times X equals 1 times 200 is 200 pounds per kilogram. Next step, I want X to be isolated. Isolate the variable for me. 202 pounds, which cancels out. That's what we want. These will cancel, leaving me with the kilograms. So I just need to divide. 200 divided by 2.2. Okay. Hopefully everybody also got that on your calculator. We're going to round that 90.9. We're going to give that 91 kilograms. Okay. All right, Ms. Thomas, what's next? Okay. Now that we have obtained our kilograms, next I want you to, so we've done this already, this first step. Let's go here. So here I want you to multiply our 0.5 micrograms per kilogram per hour times 91 kilograms. Okay, let's multiply that. 0.5 times 91 kilograms. Okay, does everybody see that? 45.5. We're going to round it to 46. 46 micrograms per hour. Okay, because of course the dimensional analysis will cancel that. Make sure you can see that really good. I want to make sure you understand everything that I just did. Okay, your next step, so we're going back to the formula method. Okay, and of course, the formula method is the D over H times Q that we always talk about. Desired over amount on hand times the quantity. And that's throughout your whole book. So here, I need, of course, this information. I need this here. All right, this portion. So that'll be 46 micrograms per hour divided by, we're going to come back up here, 300 micrograms. Let's divide that 300 micrograms. Okay, so I'm hoping you have that. Okay, hopefully you have that. So 46 divided by, make sure I put that the right thing in the calculator, equals 0.15. Make sure I have that. All right. Okay, so that's per hour. And our last step is to multiply. What have we not used here? The 250 milliliters. What do we say? 0.15? Okay. Times 250 milliliters. Okay. So really, you want to make sure you are using everything. So that gives you 37.5 milliliters per hour. And of course, we like to round. So that will be 38 milliliters per hour because the machine may not do 0.5. Okay, so you want to make sure you always round. If at all possible, please do so. Please do so. All right, you're on a roll. All right, the same will be for number 3 as well. Okay, same will be for number 3. You write down what you have as far as in what you need, which is the 4 micrograms kilogram per minute. I will write down the 200 milligrams as well as the 250 milliliter. And the patient weighs 120 pounds. So it will be the same as number 1. Now that I'm looking at number 3 as well. Okay, because I want you to be able to practice it. Okay, and let me see if 4 is any different. Number 4 also, you would change pounds to kilograms. 200 micrograms. Infused at 0.8 micrograms per kilogram per hour. And if you need me to, I can work that out for you. I don't mind at all. I don't mind at all. Okay, I'm just looking over it, trying to see if you need assistance with number 4. I would rather do number 4. Let me find me another clean sheet of paper. Okay, so let's try 4. All right. It says a patient who weighs 160 pounds, I'm going to write that down, 160 pounds, was prescribed 200 micrograms. I'm going to write down 200 micrograms of a medication in 100 milliliter. Let me write 100 milliliters down. Okay. In 200 milliliters. Okay, so of normal saline. Wait a minute, let me make sure I have the right problem, guys and girls. Oh, we're on number 4. Okay. 160 pounds, got it. Was prescribed 200 micrograms, got that too, of a medication in 100 milliliters of normal saline, got that. To infuse at 0.8, and write that down, 0.8 micrograms per kilogram per hour. So I know these examples are the same, but I think that you would benefit from at least seeing it over and over and over again because repetition is key. So first we want to start with the pounds. The person is 160 pounds. So let's start there. All right, so 1 kilogram equals 2.2 pounds. Okay, and the more you do it, then you'll understand it. So this is wonderful, and please bear with me as I give you many examples. So this is 2.2 pounds again, times X. 160 times 1, cross multiplying. Okay. Next, I want you to divide both sides by 2.2 pounds. on both sides to isolate the variable. So that will be 160 divided by 2.2, which equals, hopefully you got the same thing I have. We're going to round that to 73. So round it to 73 kilograms, okay? We're still on the roll. All right, next, let's look here. So I want you to multiply 0.8 micrograms per kilogram per hour times 73 kilograms, okay? 0.8 times 73 equals 58.4. So that's going to give us rounded 58 micrograms per hour. Okay, we're on the roll. Next, I want you to stack. So we're going to take this. So it's like we're taking one answer and stacking it and creating our next answer. We're going to divide that by 200 micrograms times what we have not used, which is 100 milliliters. Okay, so these will cancel. So I'm going to divide, so 58 divided by 200 equals 0.29 times 100 milliliters equals 29 milliliters per hour. So we just 1 milliliters per hour is your answer. Okay, I'm just still looking over various problems to see. If you don't mind, just let me give you one more, please. I know they're all the same, but I just like to make sure you have a good understanding. All right, let's look at another one. All right, let's look at number 5. All right, number 5 looks a little different. It says the physician prescribes 6 micrograms per minute of a medication that was available as 100 milligrams and 200 milliliters, okay, of normal saline for a patient who weighs 180 pounds. Oh, it's just like number 1. Okay, I don't want to repeat it since I know you probably thinking to yourself, Miss Thomas, we got it. But I do oftentimes like to just look through it just to see are there any problems that are different, but they are not. All of the problems are worked out the same over and over and over again. I'm just looking at number 4, 5, and 6. Okay, guys, I don't want to bombard you with so many examples. Doing it over and over again, you get burnt out. Okay. Okay, so let me zoom in to number 1 so you can see that again. Number 2 as well. I know we've done a lot of work. Okay, students, hope this helps.